The ages of man are named by the materials that shape their technologies: stone, bronze, and iron. The evolution continues as materials make the decisive difference as our civilization advances. Enter the age of composites.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
This is a story of research, development, invention, risk, and high performance. It is the story of advanced composites in Minnesota, with chapters in medicine, transportation, recreation, and aerospace. In fact, a chapter for nearly every United States space endeavor.
Listen, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
From simple beginnings back in the 40s, when Ben and Rudy Miller started developing new uses for materials in a business they named Fiberite, to this very moment as we stand on the threshold of forever, looking into miles-wide space stations made primarily of composite structural shapes, Winona has been at both the very beginning and at the leading edge of advanced composites research, development, and manufacturing. In the next few minutes, through the perspectives of many, we will review only 3 topics. What are composites? Why are they important to Minnesota? And why a school of composite science and engineering? Popular use of the word composites has grown only in the last few years. It is used to describe the new material created by combining resins and fibers. Resins, generally plastics and epoxy, are combined with fibers as common as cotton and fiberglass and as exotic as aramid and carbon. The term advanced composites also describes those materials created through a resin and fiber merging. However, the significant difference here is that instead of chopped fibers randomly oriented in liquid resin before molding, advanced composites marry exotic resins with directionally aligned continuous fiber filaments. James McIntyre is Director of Special Projects in the Aerospace Division of U.S. Operations for Martin Marietta Corporation. His role in the Space Shuttle program allows him an intimate understanding of composites.
The real use I see of composites on towards the future is the fact that we have today probably stretched traditional, or I should say classic alloys, probably to the farthest limits that we can in aerospace, and these new kinds of composite materials are really the hope of ongoing projects. That's what, the composite really is the future in the industry.
Ron Hawley, founder and vice president of technologies for Polymer Composites Incorporated in Winona.
In the future, with higher technology composites that can replace metals on a performance basis, we'll start seeing some of those metals applications that we haven't seen in the past. It takes a new generation of plastic materials to do that. And I see those things being developed in industry today.
Characteristically, what it's allowed us to do is to be able to dream dreams of the size of a space station. The future is really there with composite materials, which allows an engineer to really be able to design beyond what would be otherwise be limitations of today's metals and alloys.
Composite materials bring high performance capability to products which could not even exist without them. Extruded, pultruded, injection molded parts of endless variety. Transportation, medicine, aerospace, and recreation. In all of this, it's important to note that every craft launched in the U.S. missile program and the U.S. space program contained materials sourced here in Winona, Minnesota. Every 747 that flies today carries 14,000 pounds of passenger cabin parts made from materials sourced in Winona. As time and technology advances, more aircraft parts and airframe components are being converted from traditional materials to composites. Here's Minnesota Governor Rudy Perpich.
During the recent around-the-world flight of the Voyager, there were numerous references made to an earlier aviation feat. 60 years ago this May, Charles Lindbergh, whose character was forged in a small Minnesota town, stretched the horizons of human achievement in space when his plane touched down in Paris after a 33-hour flight across the Atlantic. Charles Lindbergh exemplified the loneliness of leadership, the daring of discovery, and the best of the human spirit.
ABC News commentator Paul Harvey.
Are we celebrating the last first in aviation? Dick Rutan thinks not. He says that what we can do is limited only by what we can dream. President Reagan will present Rutan and Yeager and the Voyager designer brother with the Presidential Citizen Medal for service to the country. He calls them pioneers in the finest American tradition. It's interesting, even the Soviet news agency, even TASS, compared Rutan and Yeager to such pioneers as Lindbergh. Fallout from the Voyager Odyssey will include future featherweight construction of aircraft, increased use of the stronger, tougher graphite fiber will let us fly farther on less fuel, and in military aircraft it might escape detection by enemy radar.
Brought to Winona by Ben and Rudy Miller, Stanley Prozen is now president of Diversified Fabricators, the largest carbon fiber pultrusion company in America, and one of the many local Fiberite spin-off companies. Recognized around the world as the father of advanced composites, Stan was the first to merge resin and carbon fiber to produce an historic part, a fact which he only reluctantly acknowledges.
Well, okay, I'm not so sure I'm the first, but I think I am. But it was back in 1963, like I started, that we were working on the mine cases and reinforced plastics, trying to improve properties so that they would withstand all these hostile environments, like submarines. In those years, we worried about the submarine thresher going down, if you remember that. A couple of fellows that I knew were on that thresher. And so the thing was, well, let's find materials where if people get trapped underwater, let's go down and find them. So you got to get something stiff, something lightweight, and something that's buoyant enough to come back up. Well, of course, we started looking at these materials, and one day the people from Union Carbide came to see us at the Navy, at the Naval Ordnance Lab. Said, "Look, we got this black fiber." That's what they called it. And I guess, not knowing any better, I says, "Have you got some you can give me?" And so, "Oh, yes." They said, "What do you want to do with it?" I said, "I want to try a couple things." But I took it back and I made what I call an NOL ring. It's a 6-inch ring. It's a standard test ring now. And I made this ring and tested the ring and showed, yes, indeed, that the properties that were inherent in the fiber were also in that ring.
From quiet beginnings with Stan, advanced composites are rapidly becoming essential in the process of materials replacement necessary in transportation, recreation, medicine, and aerospace.
What composites allow us to do is to build the dreams that we dream. If we weren't able to have composites available, we would have to live within the constraints of classic metals and alloys. And they have really allowed us to look into the 21st century.
Dr. Dennis Nielsen, Dean of the College of Science and Technology at Winona State University.
Part of the mission of each of the 7 state universities is to work with local industries, businesses, to assist them with their development, prospering, and growth. When we started our Business Industry Alliance at Winona State several years ago, it became quite obvious to those of us who were involved that we had a very unique situation here in terms of the type of industries that are located in Winona. Winona is recognized nationally because of the composites industries that are located here. Well, once we started seeing what was happening, we became aware of the fact that we're in a major transition in our industries, nationwide, worldwide. We're going from the metallic age to the composite age, in a sense. And as a result, I think education at this point is kind of been caught short. We're not keeping up with the changes in industry. When we realized that there was no engineering per se at the undergraduate level that deals with composite materials, we said, hey, we got a problem here. Industry was telling us there's a problem. There's 500 job openings a year for engineers with composites experience. We're producing maybe 80 in this country. That's a problem. Yet we're looking at an industry that's growing anywhere from 10 to 20% per year. Where are these scientists going to come from?
Looking into the future of composites nearly 11 years ago, the widely published Dr. Byron Pipes, former director of the Center for Composite Materials and now the Dean of the College of Engineering at the University of Delaware in Wilmington, is familiar with the Winona State University plan.
Well, I think that Winona has a unique opportunity with the locale of a number of intermediate-sized industries that are at the forefront of this technology. And in addition to that, you have a number of entrepreneurial, smaller companies that are coming into being that I think will be providing some real opportunity for growth. It's been projected, for example, that this industry, which is at present a $1.5 billion per year industry, should exceed $12 billion per year by the year 2000. It's a relatively highly attractive form of industry in that it's clean, low profile with a range of high-paying, highly skilled jobs. I think that the work ethic that Minnesota has always demonstrated, the locale of that industry, and the opportunity to design an undergraduate program which focuses in this area is a very special combination of conditions which should lead to success. I think it's an exceptional opportunity for you.
Starting up has advantages.
When you have an academic program that's underway, it's very difficult to change it to accommodate some of the new thrusts. But when you're defining the degree as you are, you can develop it, you can form it as you wish. So you have an advantage, in my view, over some of the first-class schools, and Minnesota has a first-class higher education program, in my view. But you have an advantage over those who have existing programs because it's easier to formulate a new program and accommodate this field than it is to change an existing one. And we ourselves have found that to be the case here. And I think that's certainly true in your case.
We're not trying to duplicate any program in the state, anywhere in the nation. What we're trying to do is to support these industries in our area and to develop a new area that is unique. In other words, we're carving out our niche in this state.
On the face of the earth, Winona occupies a precious place in time and space. Steve Bowen, president of Polymer Composites of Winona.
Winona is unusual. It's unusual because, related to composites, because of the percentage of jobs in this one industry.
Fiberite and RTP companies, industry leaders founded in Winona. Polymer Composites, advanced composite formulations, tooling, and process. Turtum, engineering composite materials for aerospace, consumer, transportation, and recreation. Diversified Fabricators, America's largest carbon fiber pultrusion company. Winona Canoes, designer and builder of internationally acclaimed competition and pleasure canoes using composite technology. MechPro, developing special tooling for the industry.
And it is unique. It is unique in the country and probably in the world. A very large and somewhat similar metropolitan area in terms of the scope of composites and the impact on that workforce in that locality is the Wilmington, Delaware area, where DuPont, ICI, Hercules, BASF, and a number of other major chemical companies who are deeply involved in composites are headquartered. And there they have made a commitment to sponsor university programs with the University of Delaware. They're heavily endowed and they have an active industry academic interface, and it's been most successful. On a smaller scale, but of equal importance on that smaller scale, this would be a similar program geared to the undergraduate degree rather than the graduate school.
President of Winona State University, Dr. Thomas Stark.
Well, there's a national and international need for people in this burgeoning industry. The university has a responsibility to be forward-looking, to try to anticipate the needs, employment needs of people, employment needs of the industry, I really should say. And composites is the wave of the future. So our university needs to be in place so that it can address those needs and provide people to work in that industry.
So we started out with this idea that we would have an option in the physics major that would deal with composite materials. Well, when Governor Perpich visited our campus in the summer of '86, he was so impressed with this business industry education interaction and the excitement of the potential for economic development that he said, you don't need an option in that physics major, you need engineering.
But I also think it's important, and it becomes a product of Minnesota, a renewable resource, to be able to produce people that can seek employment throughout the country and in turn draw other resources such as financial resources and grants from other industrial concerns to sponsor work and research and development in this area at the Winona State University.
The state university system also has moved to clarify its role and will become the major provider of undergraduate education. Our state universities will increasingly become regional economic development centers in greater Minnesota, serving as catalysts for long-term economic growth and vitality.
I think he's a governor that has a lot of vision. I think he's impatient about, in some respects, about the way we're responding to the changing economy and the changing technology. And he wants new business in this state, and he wants existing business to prosper and grow.
Winona State University, a choice for the location of a school of composite science and engineering.
Well, it makes sense in Winona for a number of reasons. One is that this is a national center for the manufacturing of composites. We believe that as a university, we need to do more than educate people, but to serve in economic development and work with business and industry. With that very major industry located here in Winona, we've developed relationships with those companies to help them do their work better. At the same time, we provide needed learning laboratories for our students. So the industry is here. That's one big reason. The laboratory surrounds us at the university. The second major reason is we have provided the basis and the head start for moving into an engineering program. Another reason is that we've developed with our area of vocational technical school a 2-year technicians program in this industry that is like, again, the first step to an engineering program. With the Alliance, we've developed a center for materials research and testing, and we do a lot of work with that industry. Next logical step is to start a school of engineering.
I think it's definitely the logical place to put the school, because I think if you're going to look at high technology industries, you have to have the close support of high technology education. The two are intimately linked. You cannot separate them by 100 miles anymore. They have to be together.
I think it's very logical. If you look at the composites industry in and around Winona, we have a wide variety of companies, manufacturers, making and using plastics. And they all have different requirements, but they all need composites engineers.
The window of opportunity is a finite one. That that inaction in responding to this opportunity is the same as negative action. I believe the window of opportunity not only for Winona but for Delaware and for the United States, for that matter, is open. But if we don't step into it, it will close, and we will lose our position internationally. And I think that for that reason, I'm anxious to support the Winona effort.
I think in many opportunities, there's, to use the cliche, a window of opportunity. Not only do we have a responsibility as a state to keep that industry in Minnesota, but when in keeping it here and supporting it and nourishing it, it will bring along with the other supportive industries that are a part of it. It's just a grand opportunity that we have. We can't let it escape from us. We have just a short period of time, I think, in which to capture the moment.
I think that it should mean a great deal to the state. It should highlight the state in an emerging new industry, new high technology, and I would like to see Minnesota become the next Wilmington, Delaware. And I think Winona's becoming that type of a community.
It's very easy for us to get caught up with what does it mean for the 30-some thousand people that live right in our area. And that's important, there's no doubt about it. But that is minuscule compared to what it means to the state and really to the nation. If we as a state can get into this industry so that it is the place where businesses that are developing now can continue to be and can operate with the kinds of support that they need so they can be profitable, then Minnesota will be in an absolutely enviable position among the 50 states.
The hurdles ahead are great, but the opportunities are even greater. And the special Minnesota spirit is poised for the challenges we face together. Our objective in the next 4 years is to bring out the best in Minnesotans to ensure opportunity for our children. We must be sure that all of them have quality job opportunities. Our goal is to make Minnesota a model state, to make Minnesota a brainpower state, and to make Minnesota a world-renowned research center.